Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Thoriq Alfarizi and my student number is 2206055265. And in this video, I will give an answer to an optimization example problem and using the DAI5 problem solving method. So we have a problem here, which is optimizing a logistic regression model using the gradient descent. And given to develop a logistic regression model to classify a dataset and use gradient descent to optimize the model parameters and assess the effectiveness of different learning rates and stopping criteria to find the optimal solution. So, first is the solution using the conscious thinking steps or the E5. First, we have intention. And intention, we can reach out to a goal, which is to optimize the parameters of a logistic regression model to achieve the highest possible classification accuracy on a given dataset. And the criteria is convergence of the gradient descent algorithm, minimization of the cost function or cross entropy loss, high classification accuracy on the validation dataset, and efficiency in terms of computational resources and time. And of course, all of that for the sake of God. And the second step is initial thinking, which has problem identification. And it also has understand the structure of logistic regression and the role of gradient descent in parameter optimization, and to identify the features and target variable in dataset, and to define the logistic regression model and its cost function. And we also have method selection, which has choose gradient descent as the optimization method and evaluate different variation of gradient descents, for example, batch, stochastic, and mini batch, and also select appropriate metrics to evaluating model performance, for example, accuracy, precision, and recall. And the third step is idealization. In idealization, we have assumptions, which is to assume the dataset is clean and pre-processed. For example, no missing values, features normalized. And we have to assume that the logistic regression model is appropriate for the classification problem. And we also have to assume a reasonable range for learning rates and stopping criteria. And we have the modeling, which has the mathematical model. And we defined the logistic regression hypothesis function. And this is the model. And this is the model for logistic regression hypothesis. And this is the cost function or the cross entropy loss. And this one is for gradient descent. The gradient descent update. And after all, we have the mathematical model. We can approximate and we can set the error tolerance. And by that, we set acceptable levels for the learning rate or alpha over alpha, and stopping criteria, for example, number of iterations, change in cost functions. And we have instruction. So in instruction, we have algorithm development, and it has 7 points, which is initialize parameters, compute predictions, compute cost, compute gradients, update parameters, check convergence, and repeat. and and finally, the implementation. Now I implement this with Python code. We have the code right here, and I already copied it. And for example, for today, we're going to run the code, and it prints the answers. which is this. And we're going to copy the answers and we're going to paste it right here. So we can read it clearly now. So we have iteration zero at, this means that iteration at time zero. So the cost is 0.6098 and so on. Iteration at 100. The cost is 0.64389 and so on. And all the way to iteration 900, which has the cost of 0.53950 and so on. And we have the also the optimal parameters. This is also important. So we have the parameters, which is minus 1.0710671 and the second one we have a space right here. Okay, and the second one is 0.2792754. After we have our answers, by running the code we can conclude it. So using the conscious thinking method for optimizing a logistic regression model with gradient descent ensures a structured, thorough, and effective approach. This method enhances understanding, improves decision making, and leads to optimal solutions by systematically addressing each step from goal setting to implementation and verification. This reflective practice is invaluable for continuous improvement and deeper understanding of optimization in numerical methods. So that's it for optimizations. I hope you enjoyed. Assalamualaikum warahmatullahi wabarakatuh.